Dear all, kindly wait for a few more minutes so that the resource person can join.
Good afternoon, ma'am.
Good afternoon, sir. Start.
Am I audible, ma'am?
Yes, sir.
One second.
A very pleasant afternoon to everyone gathered here. With immense joy, I welcome you all to the fifth and final day of our 5-day faculty development program on recent trends and emerging technologies in computer science, innovations, applications, and research perspective. Organized by the Department of Computer Applications and PG Department of Computer Science, St. Joseph's College Arts and Science, in association with IQAC and IAC. We are indeed blessed to have had an enriching journey throughout these days, gaining valuable insights from eminent resource persons. To begin this day on a divine note, I kindly invite Mrs. D. Kalayarasi, Assistant Professor, Department of Computer Applications, to lead us in prayer.
Loving Heavenly Father, we come to you this hours asking for your blessing and help us. We are gathering together in this 5 days FDP on recent trend and emergency technology in computer science, innovations, application and research perspectives. The Pope, our blessings upon our founder father and chairman. Reverend Father Dr. J. Arukraj, administrated Reverend Sister Dr. M. Baby, our principal Dr. R. Ruben, and also our resource person Dr. B. Karthikeyan, and on all the faculties of our various institutes. Let this FPP will be an effective learning tools for all of us who have joined in these sections. We give enter FDP in our mighty hand. We ask this prayer in the name of our Lord Jesus Christ. Amen.
Thank you, ma'am. Every gathering becomes meaningful when we are warmly welcomed. To deliver the welcome remarks, I now invite Dr. N.G. Tangama, Assistant Professor and Head, PG Department of Computer Science.
It's a great honor and privilege for me to welcome you all to this special occasion. A special thanks to Founder Father, Dr. Chairman Reverend Father Dr. J. Arulraj, Administrator Reverend Sister Dr. M. Baby, Principal Dr. Ruben for the constant support and encouragement. Today, I welcome our resource person, Dr. B. Karthikeyan, ME PhD, Professor, Department of Information Technology, Animal Engineering College. We look forward to your inspiring words and valuable insight. Thank you and welcome you once again, sir. Thank you.
Thank you, ma'am. Am I audible?
Thank you, ma'am. Knowledge shared by experts always adds immense value to our academic and research journey. To introduce today's distinguished resource person, I now call upon Mrs. G. Niveta, Assistant Professor, Department of Computer Applications.
A very good afternoon to one and all. It is indeed my privilege to welcome our distinguished resource person, Dr. B. Karthikeyan, to today's session. Dr. Karthikeyan is currently serving as a professor in the Department of Computer Science and Engineering at Panimalar Engineering College, Chennai. He brings with him an immense academic and professional journey with over 22 years of teaching experience and valuable industry exposure as a senior software engineer at Satyam Computers. He holds a PhD in Information and Communication Engineering from Anna University and has also completed his MTech in IT with distinction. Dr. Karthikeyan has a strong research profile with 16 publications in international journals and conferences, including 11 Scopus Index paper. His area of interest include artificial intelligence, machine learning, cloud computing security, and computer networks. He also guided projects, delivered expert lectures, and contributed patents and copyrights in the field. We are truly honored to have such a distinguished academician and researcher with us today. On behalf of the organizer and participants, I extend a warm welcome to Dr. B. Karthikeyan and look forward to this insightful session. Thank you.
Thank
Thank
you,
you,
ma'am,
ma'am.
for the wonderful introduction. We are indeed privileged to have with us Dr. B. Karthikeyan, Professor, Department of Information Technology, Panimalar Engineering College. Sir, we are delighted to have you here with us, and we now hand over the session to you.
Ma'am, am I audible?
Yes, sir, audible.
Yes, ma'am. Thank you, ma'am. Thank you
Thank
for
you.
your introduction.
Thanks.
Now, I'll directly go to presentation, ma'am. Is my screen visible, ma'am?
Yes, sir, visible.
Yes. Yes, ma'am. So, good afternoon to one and all present here. Today's topic is introduction to big data and data analytics, and we are going to touch some part of data analytics in Python, using Python. First of all, we need to understand what is big data. So, what is that big represent? So, it is really a big is related to size. Yes, it matters. Sizes matters because the big data normally range between terabytes or petabytes or zettabytes, even more, right? So, do anyone knows what is zettabyte is? Zettabyte. So it is around 1 GB we know, right? 1 GB, 1 TB, even 1 TB we know. 1024 TB, that is that comprise of 1 petabyte, and 1024 petabytes, that is equal to 1 exabytes, right? And 1024 exabytes, that is equal to 1 zettabyte. So today our data is growing in a zettabyte speed. So you just think of how fast the data is growing. Right? So apart from the size, the big data, it is the properties varies from time, diversity, and distribution. Right? So time that gives you, so for example, 1 seconds, how much data is generated. So for example, um so we'll go to this part. So this is the volume of data that is generated in a second, right? So 2025, 181 zettabyte of data is generated per second. So you just think of how fastly the data is growing, right? So that is a time. And diversity means the data which is generated, it is not with single structured or single source, right? So the data is generated from multiple sources, from Excel data to web pages to audio, that is audio to videos, that is what is the videos you are looking at YouTube, or the video generated from the surveillance cameras. So these are the mixed type of data which all are generated time to time, right? So this shows diversity of data that is generated. And data distribution. So data distribution in the sense data is distributed from not only from one source, it is generated from multiple sources. So this comprise the big data's property, right? So the big data means it is not related only with the size, okay? It is related with the time, and it is related with the diversity, and it is related with the distribution. So, so now we need to define what is big data is. So big data is like high volume, high velocity, and high variety of data information, which can be stored and which can be analyzed. Okay. So and analysis should be of cost effective and information processing in a fast manner. Right? So these are the three V properties of big data, which we have seen already: volume, velocity, and variety or veracity. Okay, so this is the rate of data that has been generated day to day or in a second of time, right? So in 2020, we had only 64.2 zettabyte of data generated. Now it becomes three times, like 181 zettabytes of data um, generated each second. So you just think of how much data has been is generating, and these data need to be analyzed so that we can go for some kind of prediction or some kind of decision. Okay, and this is the velocity in which the data is generating, even from surveillance camera, or even from your car, or even from your IoT related devices. Say for example, you just consider your watch. From your watch you can just take your blood pressure or something like that, right? So all the data is generated, and it has been uploaded in the big data, right? So this is called velocity of data and variety of data. So in the big data part, so we are not only dealing with structured data. So structured data means like a database or Excel. So these are the structured data, right? So we are not only dealing with structured data, we are dealing with structured, semi-structured, quasi-structured, and unstructured data. So all the data are being processed, right? So structured data means it is like CSV or Excel files like that. Semi-structured data means XML files with some schemas. Those kind of data are called as semi-structured data. Quasi-structured data means it's like something like semi-structured data, which is of some erratic forms, right? So erratic forms in the sense which is having more number of errors or more number of data are missing, right? So those data are called quasi-structured data. And the last one is unstructured data, where you have websites, videos, video analytics. So these kind of data are processed by your big data analytics, right? So this is some example for structured data, where you have CSV files. Semi-structured data, you have some XML file, and this is your quasi-structured data. So this is one log file generated from some router, in which we have some timestamp, IP address, URLs, and user SWID, and geocoded IP addresses, right? So this is one log file which is generated, right? So this is also a data for us to analysis, right? To analyze. So this is called quasi-structured data. And the unstructured data you know already, right? So it may be some image, or it may be some videos, or it may be the data from the web. So these are your unstructured data. Now we need to go into data science or data analytics, right? So for data science is your big data on which you are going to do some analysis, and we are going to make some decision, right? So this is called the data science generally. So the components of data science includes big data, mathematics part, probability, machine learning, statistics, data analytics. One second. Data analytics, and then business analytics, programming, data engineering, visualization, and data warehousing, and then insight of data. So this forms your entire data science or data analytics. Okay. So the data science or data analytics consists of mathematical aspects, which consist of geometry, optimization, some scientific computing, and machine learning, right? So these all are mathematical aspects of data science. And computer science aspects. So what is the need for computer science in data analysis or data science? So we are following some data structures and algorithms. We have some databases, distributed computing to analyze those data, and we have software engineering, artificial intelligence, and machine learning. And in the aspects of statistical, we need some linear models. We need to understand linear models, statistical test where we have some mean, median, and inference, and time series analysis, and machine learning concepts. Okay. So these are some of the applications of data analytics, where we have intelligent systems and robotics, marketing, medicine, autonomous driving, and social networking. So in these places, data analysis is very, very, very important. Say for example, if you take marketing, say for example, now we are using Amazon. So in the Amazon, how the product is being advertised to you, right? So the product will be advertised user by user in a customized manner, right? So that will be the output of data analytics. So what are the data you are looking? Say for example, if you are advised to buy something, means, so what are the what are the previous history you have searched in the Amazon? So that will be analyzed, and your interested topics or interested things will be marketed, right? So this is with the help with the marketing field. And in the autonomous driving, so first you need to construct one car, and then you need to have some database inside the car, right? After that, you need to look into the roadside vehicles, roadside images. So to process those images, and we need to come to one conclusion. Say for example, if we have some pedestrian path, or if we have some speed breakers, so that image has to be analyzed with the previous data, and the car has to decide whether to brake, or whether to go faster, or whether to go slower, right? So these are some of the applications of data analytics, right? So now we are coming to data analysis with the help of Python. Right? So the Python is a very, 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 very complex language in which we have all the sort of libraries which can be used for different purposes, right? So nowadays data science is the very popular thing, right? So for data science concept, the Python is having all the libraries which are readily available. So what is the thing? We can use it. We can use it, and you can easily manipulate the data, and you can go for plotting the data, and you can go for some statistical analysis, and you can go for some inferential statistics. So for all the things, the Python is having more number of libraries, predefined libraries. So that libraries we can make use of it in an efficient manner. So if you are using some other language, say for example Java or other language, we need to code more. But in the case of Python, all the libraries are freely available, so we can make use of it. Right? So we are going to see some of the libraries which are mainly used for data science. Right? So the Python libraries, the important libraries for data science are NumPy, SciPy, Pandas, scikit-learn, and some of the visualization libraries like Matplotlib and Seaborn, and we have many more libraries like these things. But these are the main libraries which are used very often. Mm. So the first library, NumPy. So this library is used to work with arrays. Right? So it introduce objects for multi-dimensional arrays and matrices. So why these arrays we need? Why we need to process these arrays in data science or data analytics means normally your database will be comprised of tables, right? So whenever you have tables, all the table data can be taken in a multi-dimensional array. Normally in two-dimensional array, but you can have it in any dimensional array. So for this operation, the NumPy is the best library which can be used in a data analytics. Right? So this NumPy provides vectorization of mathematical operations like in arrays, right? So for example, now we'll see one of the examples so that you can easily understand. Right? So this is where NumPy library, and the second library is SciPy library, which is used for scientific computations. Some scientific computations like linear algebra solving, differential equation solving, numerical integration, optimization, and statistics. So for all these operations, this SciPy is having libraries, right? So this will be mainly operating on constants like pi or some of the metrics like uh, gigabytes, petabytes. So for all the things, the SciPy is having constants, and we have some of the SciPy optimizers for solving or for optimizing the machine learning models, and SciPy sparse data where you can have some sparse data like this. Sparse data means, so it is having some of the data like more number of zeros or more number of non-data variable, right? So this is called sparse data, and SciPy graphs where we can have two-dimensional graphs, and all SciPy spatial data in which you can deal with some location oriented data. You can go for plotting the location like Uber route formation or like that, right? So spatial data means it is dealing with location data, right? So all these SciPy libraries are built on top of the NumPy library. So NumPy is the base library on which you can have all the other libraries also for data science, right? Because the NumPy is the one which is going to have your data, right? So on top of the NumPy library, we are going to apply all these other libraries like SciPy, in Pandas and all, right? So the next library is Pandas, which is used for analyzing your data, cleaning your data, exploring your data, and manipulating of your data, right? So it is adding data structures and tools for table-like data. So all the analytics operations are done with the help of Pandas libraries, right? So it is providing tools for reshaping your data, right? So like say for example, if you have some table data and you can go for transforming this data into some other format, right? And you can go for merging, right? Merging of two data sources into one data source, right? And you can go for sorting this data table, and you can go for slicing, right? Slicing means the entire table can be splitted into half, or whatever the data we want to analyze, that part alone you can go for slicing, and you can go for aggregating the data also, right? And the Python library also providing tools for handling the missing data also. So am I going very fast, or it is okay?
No, sir.
So the next library is Scikit library, which provides tools for machine learning and statistical modeling. Right? See in the NumPy we have table of data, and after that you have pandas. Pandas, what it will do? It will go for some data pre-processing operation where you can go for slicing of data, and after that you can give this data to this scikit-learn library, where you have machine learning algorithms like classification, regression, clustering, and model validation. Right? So again, this scikit library is built on top of NumPy and SkyPy. One second. Okay. Okay. So Scikit library, it is providing tools for machine learning and statistical modeling, where you can go for classifying your data, regression analysis, and you can go for clustering and model validation. And again, this Python, this Scikit library is built on top of NumPy. NumPy is the base library, where you can have all your data. Right. So next library is matplotlib, which is used for plotting your data in the two-dimensional plotting. Only it is used for, say for example, line plot. You can go for scatter plots, bar chart, histograms, pie chart, and all. Right. So this is a base library model where you can have all these base chart, right? Line plot, scatter plot, like that. So it is very relatively low level of plotting your data. And again, you have one more library for plotting your data in an advanced visualization model. That is your Seaborn library. Right? So it is used for visualizing your data in a visualizing the random distribution of your data. It is based on matplotlib only, but it is providing high level interface for drawing the attractive statistical graphics, like that. Right? So it is in our language we have ggplot library. The same usage is for Seaborn library. So now we are going to see some of the glimpse of coding in the how we can use these Python libraries, right? So all these libraries are freely available in your Python, right? So after installing your Python language, you need to install these libraries separately. You need to install these libraries separately. So how to, okay, okay. So for importing library, first you need to give pip install numpy. Say for example, if you want to install numpy, one second. Is this visible, ma'am? No? Ma'am, is this visible? PIP install numpy.
Yes, sir.
Yes, ma'am. See, whenever we want to install, so all these libraries need to be installed separately with your Python libraries, right? So first thing what you need to do is, after installing your Python, in the Python script, you need to type like this: pip install numpy. So this will download the numpy library and it will be installed in your system, installed in your Python, right? So like that, you need to install all the libraries in pip install. Instead of numpy, you need to give SIPY, SciPy, right? So for all the libraries can be installed like this, and after installing your libraries, you can go for importing all those libraries, right, for your analytics, right? Import numpy as np. So this is like an alias name, right? So after installing all your libraries, what you need to do is, you need to import all the libraries for your program like this: import and library name as some alias name. So this alias name only we are going to use in your program for all the other usages, right? So this is the way you can import all these libraries to your program, right? So this is pandas. With the help of pandas, we can read a CSV file. CSV means comma separated file. You can read. So this is like one table of data which we are going to read for our program, right? So for that, pd dot read underscore csv. Pd dot read underscore csv. Pd means pandas, right? So this is the panda library we are importing as pd. So this is the alias name which we are using here, right? Pd dot read underscore csv. Read underscore csv is a method which is going to read your csv file, right? So that will be stored as df. Df means data frame, right? So this table is represented as data frame in our Python program. That's it. Okay? So this is how you can read one data table to your program. Okay? So after reading the data, you can go for analyzing the data, right? So first, what we are going to do is, we are just to list out all the list the first 5 records. So first 5 records you can list with the help of head method. Df means data frame. Df is the data frame which consists of your CSV file, right? So in the data frame, we are just listing only the 5 records, not top 5, first 5 records we are listing, right? So df dot head. So head is the method which is listing out defaultly first 5 rows, right? 0th row, first row, second row, third and fourth row, right? But in the head, you can pass some of the arguments, right? So if you want 10 records, first 10 records, then you need to use like this: df dot head of 10. Then this will display 10 records, right? If you want to display 15 records, then you need to pass dot head of 15, right? Now we want to display the last 5 records. So how to list out last 5 records means, you need to use minus. Say for example, last 5 records you need means, you can use -5, right? Head of -5, right? Now this will list out last 5 records. in the data in the table. Say for example, if you have 100 records, then it will list out 96 to 100 records. Right? So this is the use of head method. Right? Now you can take your data type. What is the data type of your column? Right? DF of salary. Say for example, these are the column which is available in your table: rank, discipline, PhD, service, sex, salary, and salary. If these are the table data, table column name, then you can go for checking your data type of your column, right? DF data frame, square bracket, you need to mention the column name, right? DF of salary dot D type. D type is the attribute which will give you the type of the data, right? So now the D type of salary, data type of salary is int 64, integer value, right? Right. So now you want to check all the types, means then you can use like this: df is the data frame dot d types. The total data type will be displayed like this. Rank is the first column name, discipline is the second column name. So all the column names and what is the data type, it will display all the data types. So these are some of the attributes available in your data frame object. D types, so it will list the types of the all columns. The df dot columns, it will list the column names alone. Df dot axis, it will list the row labels and the column names. Right? Ndim will provide you the number of dimension of the data frame available. The size will provide the number of elements, number of rows in the data table. Shape will provide you a tuple representing the dimensionality, and values will provide you the data of the data frame. So these are the methods which is available in your data frame. So as we have seen, df dot head of n means first n rows will be displayed. Tail of n means the last n rows will be displayed. Again, you can use -5 for last 5 rows. You can use, right? So describe will generate the descriptive statistics of the entire data frame. The max will provide you the maximum values in the column. Min will provide you the minimum value of the data frame, and the mean median will provide you mean and the median values of the all numeric values present in the data frame. And std is the method which is providing you the data, standard deviation. And sample of n will provide you a random sample of the data frame, which is in the data frame. Say for example, if you have 100 data, from that 100 data, it will provide some random data frame, sample data from the data frame. And the drop NA, it will drop all the records with missing values. NA means not applicable, right? So missing values in the sense, say for example, if the database consists of most of the zeros in some of the field, then it will be dropped. Right? So these are the methods available in your data frame object. Right? Right. So you can go for selecting a column in your data frame like this. Say for example, if you want to select a column like only the sex column, say for example, this is our table in which we can take some of the columns, right? So for that, you can use df is the data frame name, and then you need to give the column name inside the square bracket. Then it will provide you the prescribed column name. Okay. Okay. So for example, and this is used for taking the column name, and again you can have another method called data frame name dot and column name. Instead of square bracket, you can use just column name in the after this dot operation. So like your database operation, you can use group by method to go for aggregating your data. Right? So for example, df dot group by of rank. So how many number of ranks you have? So you can group the data with the help of rank column, right? So in the rank we have associate professor, assistant professor, professor, right? So we have 1,000 number of associate professors, 10 or 100 number of assistant professors, or 100 number of professors. So all will be grouped by rank, right? So in the associate professor, this is some PhD value. This is the service, that is the experience of associate, all the associate professors experience. This is average value, right? And then mean value, right? And then this one is salary mean value for associate professor, right? So you can go for group by operation with the help of rank, and you can go for calculating mean value for this grouped values, right? Here we have grouped all the data in by with the help of rank column. Now the grouped value is present in df underscore rank. That again, this is also one data frame. So in this df underscore rank, we have data grouped by rank, right? Now we can go for taking mean value for this df underscore rank. So for associate professor, what is the PhD service, and then how many number of CSE PhD produced, what is the average or what is the mean value of service, what is the mean value of their experience, and what is the mean value of their salary. So all these kind of data analytics operation we can have with the help of group by method. So this is like we can group with the help of two values. We can group by rank, and only we need salary and then its mean. Then you can have like this. So in first df underscore rank dot mean, it will provide you all the mean values of other columns. Okay, but you can specify a particular field's mean value alone, right? So how to get that df dot group by of rank? First you are grouping by rank, and then you are taking only the salary column. For that you are going for applying the mean value. Then the salary part alone will be displayed. Okay. Okay. So then the group by method. So the group by method, defaultly it will go for sorting and it will produce the list, right? But if you don't want sorting and only you are going for grouping means, then you can give sort equal to false, right? So why we are giving this sort equal to false means, at in sometimes we want to group only with rank and we don't want sorting means, then you can apply this sort equal to false for better performance, right? So what the default group by will do, will group by rank, that is prescribed column value, and it will go for sorting by default, right? So if you are giving sort equal to false means, it will provide you the raw data which is grouped by rank, right? So this will increase the performance. If you don't want sorting means, then you can apply this sort equal to false, right? Okay. So then you can go for filtering your data set, right? So now the entire database or table is taken as data frame, right? So for example, if you have some 1,000 number of records, all these 1,000 number of records have been taken for DF, right? So but now you can go for filtering those data. So part of the data alone, you can take it for your analysis, right? So for example, now we are going to select the salary of professor rank, and the salary should be greater than or equal to 1,20,000, right? So for that you can use this df, that is data frame. Data frame, inside data frame we have salary column, right? So df of salary is greater than 1,20,000, right? So now this df underscore sub will give you only the professors with salary greater than, not professor, only with the salary which is greater than 1,20,000, right? Now we have applied filter on salary, right? So this is for greater than operator, where you can use other operators also, greater than or less than, equal to, greater than or equal to, all the boolean operators you can apply in the filtering.
Hello, sir. Excuse me, sir. Your voice is not audible, sir. Sir? Hello, sir. Sir, your voice is not audible.
Ma'am, am I audible?
Sir?
Ma'am, am I audible, ma'am?
Yes, sir. You're audible now.
Yes, yes. Okay.
Sir, you can proceed.
Yes. So now, if you want to select number of rows between 10 to 20 rows, 10, you can go for slicing the number of rows, right? If you give 10 colon 20 means it will display 10th row, from 10th row to 19th row, right? It will not display 20th row. So like the syntax is df of starting and end minus 1. End minus 1. So this is the syntax for selecting the rows in array. Normally in the array operation in Python, so this is the case, right? df of 10 colon 20 means it will display from 10th record to 19th record. So and you can go for, okay, so and we can go for the number of columns in the 10 to 20th rows, and you want to display only the rank, sex, and the salary column means, then you can give like this also, right? So this will display all the 10th to 19th rows of all columns, right? So for example, if you have some 5 columns means all the 5 columns will be displayed, right? But in this case, if you want to display only the rank, sex, and the salary column means, then you can provide like this, right? df underscore sub dot loc means it will provide you only the sub part of your database, data frame. Okay, so it will display only rank, sex, and salary for all 10th to 20th row, 19th rows. Okay, and you can use iLocation method to give only the index columns, right? So in here in our LOC method, you are providing the name of the column, right? So this is rank column, sex column, and salary column, right? But in the iLoc method, you can provide 0th column, 3rd column, 4th column, and 5th column. Like that, you can provide the index of the column, right? So then it will provide 0th column means it is rank, and 3rd column means it may be service, 4th column may be, and 5th column may be this one, right? So here, instead of providing the name of the column, here you are using only the index of the column, right? So this also you can use. So iLocation of 0, then it will provide you only the first row of your data frame, right? iLocation of I means I plus 1th row. iLocation of -1 means last row will be displayed, right? So if you are using iLocation of colon comma 0 means it will display all the rows, right? So normally in your array operation in Python, so this is the starting point and this is the ending point, and it will be separated with a colon, right? So for example, 1 to 100 means it will display first record to 99th record, right? So if you are leaving the square bracket with only colon means we are not specifying first and last. So it will display the entire data in entire array normally, right? So this is the thing, right? So whenever you are giving only one index, then it will be taken for row, right? If you are using 2 index like this, comma separated 2 index means the first one will be for row and the second one will be for column, right? If you are using only one index, then it will be taken for row. If you are using 2 indexes like comma separated, then the first one will be for row indexing, the second one is for column indexing, right? So this one is for row indexing. So where only colon means it will display all the records, right? Now we are providing column value also, 0th column. So that will give you only the first column, all values. This will, right? So if you are using -1 in the column means it will give you the last column and all the values in the last column, right? So this is the thing which is used with iLoc, right? So now df.iloc of 0 to 7 means 7 records, 0 to 6 records will be displayed, right? 0 to 6 records. df.iLocation of colon comma 0 to 2 means then it will give you first 2 columns, all the rows, right? So like we saw here, right? So df.iLocation of 1 to 3 means second through second means 0th or first, that is second through third rows, second 2 comma third rows alone will be displayed. In 0 to 2 means two columns, zeroth column, first column, and zeroth column and first column will be displayed, right? So this is how you can use this ILOC to slice your data frame, right? So and data frame also can be go with sorting, right? So for that you can use sort underscore values, and then in bracket you need to give in which by which column name you want the data frame with the sorting, right? So now you are selecting the service as sorting column means then the entire data frame will be sorted with a by service, right? Now we have only 0 only service, so it is displaying like this. If the service is like this, then it will display like this: 0 1 2 3 4. So the service column will be sorted, right? So by default it will sort in ascending order, right? So df dot sort underscore values, and within bracket you need to use by equal to what is the column name you want to go for sorting, right? So now df underscore sorted, this will have the sorted data frame. Now we can go for head operation, like df underscore sorted dot head will display how many number of records? First 5 records by default, right? You can specify how many number of records you want here, but if you are giving only the parenthesis, it will display first 5 records, right? So this is the output of this sorting method. Now we can go for sorting in two columns also, by 2 columns also. So for that you need to use by equal to, then you can use service and salary, right? So by service also it will be sorted, and by salary also it will be sorted, right? Okay, and here you are giving ascending equal to true comma false. So for first column, first sorting column, you are using ascending as true comma, for second column you are using ascending as false. So the salary column will be sorted in a descending order. Okay, so this is what your sorting method. Okay, okay, so these are some of the aggregation function. Ma'am, shall I take 5 minutes? 5 minutes, ma'am. 5 more minutes, ma'am.
Sure, sir.
Yes, yes. So these are the aggregation function in pandas. We can use min, max, count, sum, product, mean, median, mode, MAD, and then standard and variation. So these are the aggregation function in pandas, which can be used in the data frames, right? Say for example, if you want to aggregate with the help of min, mean, and max, then you can use like this dot agg, right? Dot agg is the method name, and what are the values you want to aggregate, what are the aggregation you want to use, means that you can give minimum, mean, and max, right? So minimum, mean, and max means departure delay and arrival delay. So for this you are going to apply the aggregate function min, mean, and max. So min for departure delay is this one, minimum value for arrival delay is this one, mean value for both the things, and max value for both the things, right? So likewise you can utilize your aggregate function like this, right? These are the methods. So already we have seen these are the methods, and these are other aggregate functions. And SEM is the standard error of mean value. Skew is the sample skewness of your data. KURT is the kurtosis value of your data frame, right? And you can go for graphically representing your data like this, right? DIST plot. It is used for distributed plot. It's like histogram. So this is one of the example for distributed plot value. And bar plot you have already known, right? Violin plot is like this. You can display your data in the violin plot, and this is one example for box plot. Box plot, right? So these are the other plotting available with your pandas library, right? So basic statistical analysis, you can use linear regression, ANOVA test, hypothesis testing, and all the other statistical analysis you can do. And in the scikit-learn library, you can go with these kind of machine learning algorithms like k-means clustering algorithm, support vector machines, and random forest algorithms. All these algorithms are available with your scikit-learn libraries, right? So these are the statistical analysis you can do with the data frames with the help of scikit-learn library, right? So that's all about data analytics using Python. So I have given only the glimpse of the libraries used in Python. And we have a lot more of libraries which is available freely in your Python. You can make use of it. Okay. Thank you for your patience, ma'am. Sorry for the delay. I thought it was like 2:30 to 3:30, but sorry, ma'am.
It's okay, sir.
Thank you, ma'am. That's all. Any doubt, ma'am? Any doubts or any queries?
Participants, you can raise your queries. Sir, I think no queries.
Okay, ma'am.
Thank you, sir.
Thank you,
Today's
ma'am.
session on data analytics using Python was truly enriching, offering valuable insights and practical perspectives. We sincerely thank Dr. B. Karthikeyan, Professor, Department of Information Technology, Panimalar Engineering College, for sharing his expertise with us. Dear participants, may I kindly request everyone to please switch on your cameras so that we can capture this wonderful moment together. Thank you, everyone. As every good thing must come to close, it's now time to express our gratitude. To propose the vote of thanks, I warmly invite Mrs. E. Babi, Assistant Professor and Head, Department of Computer Applications.
It's my privilege and honor to extend the vote of thanks on this occasion. On behalf of the Department of Computer Applications and PG Department of Computer Science, I would like to sincerely thank our founder, Reverend Father Dr. J.R. Raj, and his continuous support. A special thanks to today's resource person, Dr. B. Karthikeyan, Professor, Department of Information Technology, Panimalar Engineering College, for sharing the valuable thoughts and expertise in practically about data analysis using Python. Thank you, sir. My heartfelt thanks to our administrator and sister M. Baby and our principal Dr. R. Ruban encouraging us throughout the planning and execution of the FDP. Next, I thank all the participants who patiently supported us through these 5 days FDP. Finally, I extend my gratitude to all the HODs, program coordinators, faculties, and technical team members. Thank you all. Thank you all once again.
Dear participants, the feedback link for today's session has been posted in the chat box. Kindly make use of the link and submit your feedback without fail. It's mandatory to get your certificate. And the certificate will reach you in next week. So with this, we gracefully conclude our 5-day faculty development program. On behalf of the Department of Computer Applications, we sincerely thank each and one of you for your active participation and enthusiasm throughout these sessions. May the insights gained here inspire your teaching, research, and professional journey. Wishing you all the continued success and a pleasant evening ahead. Thank you.